who here already knows what Ekahau is? Hey, okay, fantastic. So you guys already know it all. So thanks very much, it's been a pleasure. So in a nutshell, there are three things that Ekahau, three products and three things that Ekahau does really well. Number one, we have a product called Ekahau Pro, which is the software that lives on your computer. You can do Wi-Fi simulation, Wi-Fi survey, and then report document generation. The second thing is we have a hardware product called Sidekick. So that's this unit here that I have lovingly placed on the floor. Sidekick is a box with two Wi-Fi radios, a high-resolution spectrum analyzer inside, and a battery pack. There's a whole bunch of other stuff in there as well, but basically that's what it is. And it allows us to do Wi-Fi site surveys, collecting and to perform a passive site survey using the two Wi-Fi radios inside the Sidekick. Sidekick can be then plugged into your laptop, be that Windows or Mac OS, connect to Ekahau Pro, and then we can perform site survey. Or with Ekahau Connect, which is the latest offering from Ekahau, you can use an iPad for your site survey. So I'm going to try and keep these slides to a minimum. Like I say, we recently launched Ekahau Pro version 10. That was a large code rewrite. Hopefully some of you have already seen that and have experienced it to be an improvement. Sidekick, just explain what that is. We don't need to read through the slides. I'm losing passion for slides, and especially when people read through the slides. I don't want to give you the audiobook version of the slides. This is what I've just explained. So Ekahau Pro, Ekahau Sidekick, we know them. And then Ekahau Connect contains the survey for iPad app, Ekahau Capture, which is a packet capture tool using the radios of the Sidekick, and Ekahau Cloud, which is an optional part of Connect, giving the ability to push project files up into the cloud, access them from the iPad, but collaborate on project files as well. So you may have multiple engineers accessing the same project file, adding survey data, and then you hit back, it's synchronized, it pushes those changes up to the cloud, and then they are synchronized and merged on somebody else's computer. Okay, good, Ekahau Cloud. This is a beautiful animation of the idea behind the collaboration aspect. You can create a project on your iPad using the camera. So maybe you want to take a picture of a floor plan. Ideally, you've already been sent those floor plans, but if not, you can create your project on the iPad, push that up into the cloud, and then share that project with other Ekahau Connect users. And then Ekahau Capture. Lovely. That's it for the slides. Now let's go into the really dangerous part, the live demo. So, this one here. Excellent. And I haven't checked. Are there any questions coming in so far? No. But don't be shy. Or just ask a question at the end of the session. That would also be good as well. But yeah. There's a new version out, but I'm not using that version. So, this is what Ekahau looks like on first launch, but what we're going to look at right now is some of the exciting stuff, some of the data that's coming in from the Sidekick. So if we pop out the real-time frequency monitor, or RTFM for short, and then we'll make this big. All right, so on this screen right now, in the lower portion of the screen, we have the data coming in from the Wi-Fi radios, so passive scanning of the 2.4 gig band, and up in the top portion of the screen is the live spectrum of energy being received by this unit right now. Along the x-axis, frequency, but we have it denoted with channel numbers. On the y-axis, the power level in dBm received by the Sidekick. And we represent utilization, so duty cycle, by color. Black and dark colors indicate high utilization. White means zero utilization during the past 5 seconds, and you can change this duration if you wish to. And over here, we see the historical view. What we can see there in the middle is the curved shape of 802.11b. That's most likely to be an access point broadcasting beacons using 802.11b. So the DSSS modulation. And in the 2.4 gigahertz band, we would see signatures with a flat top, and that's OFDM, so 802.11gn in the 2.4 gig band. So now for something a little bit more exciting. I have here a video camera. This is a non-Wi-Fi device. This is an analog video transmitter. It operates in the 2.4 gigahertz band, and when I switch this thing on, we should pretty instantly start to see that energy affecting the spectrum in the 2.4 gig band. And so what we see here is the typical video transmitter signature. It looks a little bit like the Disneyland castle. The center channel, the center spike there is video and audio channels on each side. In version 10 of Ekahau, we introduced the interference detection feature, and you can see that this portion of the spectrum is being marked out to say something is affecting this portion of the spectrum, and based on our pattern recognition, we think this is a video camera. I'll turn this thing off now. Actually, let's change the channel so we can just see that looking through the spectrum there. During survey using Ekahau Pro, if interferers that we understand are detected, they will appear on the map for you. If I open up one of these projects, so many of you have performed a site survey before. You know that as you do the survey, as you perform the survey, passive survey data is being collected, and Ekahau Pro will place the APs for you automatically. If you want them, if you wanted to, you can disable that behavior. In version 10, we have the ability to identify and drop those interfering devices onto the map. Now, this will only work with the devices that are in our signature library, but I think that's a pretty cool feature. That is something that I would have liked to use when I was a customer of Ekahau's. So that's Ekahau Pro I'm running it on Mac OS, but Windows and Mac OS. And what I would like to show you next is the iPad app. Now, to demonstrate this to you, I have to do a little bit more messing around with the equipment, so just bear with me one moment. In this brief moment, does anybody have any questions about Ekahau? That's a no. Okay, that's fine. So what we're going to do is, fingers crossed. Well, maybe we won't. Maybe we won't show that piece off then, because I don't have that with me. That's fine. So let's skip that one for the minute, and let's look at performing a survey using Ekahau Pro with a Sidekick. Okay. So for this, we will fire up a new project, and we'll bring in the floor plan. Okay, and so here is our virtual environment. And we do need to set the scale, so I'm going to eyeball this and say this is what? 3, 6, flat, 12 meters? Let's try that. So we'll set that to be 12 meters, hop over to the survey tab, and then we have the two options for continuous or stop and go survey. On Windows, you can use GPS. hit continuous survey, and then we click on the map to indicate where we are right now. Then I would walk with my device in a straight line at a consistent speed. And then when we reach the other side, hit the click on the map. So we must click on the map every time we change speed or direction, okay? And then we'll come down this way, this from here. Okay, and so that's a left click each time, do a right click, and then that ends that survey. So during that brief period of survey, 14 APs were detected. We can see that 10 of them were not detected at a signal strength great enough to be placed onto the map. The threshold is -55, so any AP that is detected stronger than -55 will be placed automatically onto the map. And we now triangulate that location, so you can see that my survey path was around a square, and the APs have now been placed in the middle of that square. So the more data that you add to your projects, the more accurate these AP locations will be. And sometimes people ask me, like, Nick, Ekahau Pro's not so accurate at placing the APs. Ekahau is not really an AP finding tool. It's the Wi-Fi side survey. We're more interested in the visualizations of signal strength and signal to noise ratio that are coming from the radios inside the Sidekick. But the triangulation method should be an improvement upon being placed on your survey paths. Now, during the survey, the spectrum data is being recorded, and you can review that by going to the Survey Inspector tool, and that gives us the ability to then review the data that was recorded during the survey. And you can see here that you can walk your way through that, although there's nothing happening in the 5 gig band. So let's go back and look at the 2.4. There you can walk through the survey data that was recorded. You see the Wi-Fi data down here and the spectrum data over here. So that's it from the survey point of view, but the other thing that I said Ekahau could do was the simulation of wireless networks. So very quickly, I will fire up another map on here, and we'll bring in a new map, and this time it will be a giant wide open space. So here we have 4 playing fields back to back, and we configure the scale like this. And when performing a simulation, it's on us as wireless engineers to provide the information to the software so that you can simulate your environment. And so if the building that you're working on already exists, fantastic. You can visit that site, take some measurements of wall attenuation, and then build a model using that data. If the building that you're trying to create a wireless design for does not exist yet, then maybe you have to guess a little bit, okay? But you can do a initial plan using guessed values, and then visit site during construction and try to take some measurements of the attenuation values. I was having a conversation yesterday, and I was asked what is the best practice in that scenario, and I would say if you need to provide network drops ahead of time before that building has been constructed, I would suggest you err on the side of caution and put network drops in the ceiling all over the place, in every position that you might conceivably want to add an access point. During the building construction, it's considerably cheaper to install those network points while that building is under construction than afterwards, where you have to bring cabling engineers back into the building and add more network points. So onto the simulation side of things here. This area does not have any walls at the moment, and I can come along and just drop a virtual access point into my project. Here we see the library of APs. This library is updated with each release of Ekahau, and If there are any APs that are not modeled, then let us know at support, Ekahau support, and then we will reach out to those manufacturers and request the antenna patterns so we can add them to the software. So let's go with a 2800. So I'm going to drop a 2802i access point into the project. I drop this one down here. And so here we see a beautiful round circle. In empty space, this is theoretically what the antenna coverage would look like. And if we look at my simulated AP here, we see that it's at a height of 2.4 meters, and we can also see the transmit powers of this AP. The reason I wanted to show you this in an empty space is because all of the visualizations inside Ekahau are two-dimensional. So it's always from the bird's eye view, but you can manipulate the objects in 3 dimensions. So if we take this access point and I start to tilt it as though we were going to install it on a wall, I will just put in 90 degrees in here. Now you can see that we have taken a circular coverage area from the AP when it was mounted on the ceiling, tilted it through 90 degrees, and now the energy is going up and down. I've been asked, am I allowed to put APs on the wall? Yeah, you can put APs on the wall. Is that a question?
Yeah.
Excellent.
Does Ekahau, you want to go? Does Ekahau,
Does Ekahau have plan to add 3D restriction object like stairs?
So currently, no, I'm not aware of any plans to do this, but maybe I can take this opportunity for all of you guys who are Ekahau customers to check out ekahau.com/feedback. So we recently launched a forum for users of Ekahau to give us feature requests and feedback, so we can start to understand what features customers are missing. So at the moment, it's an invitation-only forum, but if you go to ekahau.com/feedback, you should be redirected there, and you can then apply for an account, which will come to me, and then I'll say yes, and send you an invitation. That is the best place to log that kind of information. The interesting thing there, I would say, though, is I think stairwells is a good point. Actual 3D visualizations, I'm not sure how useful that would be overall, but definitely objects like stairwells, I can see there being value in being inside Ekahau as an object. Definitely. Any other queries at the minute? Okay. This was just to show you manipulation of objects in 3 dimensions, although the visualization is 2D. I'm going to undo this and move that AP back down to, background to being installed on this ceiling in the middle of nowhere. And just show you that if I come along with a virtual wall, so we have a wall material library in here. This is the default material library. This is not a set in stone. Get it? Basically, these values are not for sure, right? You can manipulate these wall profiles. You can create your own custom wall materials. But for now, I'm going to select the concrete wall, this one here, and just draw a concrete wall over here, and hopefully we see the impact of this. And so, with our projects, the more accurately we can define the wall materials, the better the results. Okay, it's a simulation. So, what I think is valuable is the idea of the hybrid approach, where you come up with your wireless design, and then you visit site and you validate a few of those AP locations. Not necessarily every AP location, but of course it does depend on the project. All right. let's see. Anybody here have worked with CAD files for their on the projects? Show of hands. Nobody? A couple of people. So when you have access to high quality CAD files, you then do not have to draw the walls manually. You can import DWG and DXF files into Ekahau, and they will give you the ability to assign those virtual wall materials to the layers of the CAD file. So if we go into this CAD file, by the way, this CAD file is perfect for demonstration purposes. This is why I'm using it, because there are only 20 layers, or 20 or so. If your CAD file has 1,000 layers, this process is painful. If your CAD file has 1 layer, this process won't work. So if you are involved in these projects where you have access to the architect and you can request a simplified version of the CAD files that just gives you interior walls, exterior walls, windows, elevator shafts, stairwells, then you can dramatically speed up that wall drawing process. So in here, I can select the layer that's called doors. Here are all the doors that have been highlighted in blue, and I can assign a wall material to them. So we will say that these are solid wood door at 6 dB. Go down to exterior walls. These guys are concrete. The interior walls. Notice in here that some of these walls are actually 2 lines. The engine will not draw 2 3 dB walls, it will only draw 1. It understands that this is only 1 wall. So we'll assign this to be a dry wall at 3 dB. And then if we look at the stairwells, we will configure them to be concrete at 12 dB. Same thing here. Notice that the stairwells have a line for each step. That's not what we want, but the engine will not import walls for each step in this scenario. The scale has been set automatically because it came from a CAD file. We will assign a layer for the windows. Hit import, and then Ekahau will draw those walls for us. So now that we get to this point, we have the opportunity to change the visualization over to coverage planning. And coverage planning is a preview, if you will, of the coverage data. So it is faster, it is less accurate than the signal strength, but in here I can go to my simulated AP tool and then select that. Well, let's try and keep the vendor changing, shall we? So let's go for my personal favorite, Ruckus AP, and then you see I can move this AP through the building, and it's giving me a quick, rough visualization of the cell that this AP would create in these locations. So we can come along and drop APs like this, like a real pro, right? This is how the pros do it. Sometimes this can be pretty useful actually if you want to demonstrate how important the AP location is. If we talk about Wi-Fi in hallways, so Wi-Fi in hallways is a contentious subject, and if we put lots of APs in the hallway, they can all see each other nice and clearly, but the clients that they're trying to serve are in the rooms, probably, and you end up with lots of co-channel contention. But so sometimes in design, I wish to keep my Wi-Fi not out of the corridors, but limited. And like here, you can see if I put my AP here, there is little signal shooting down that corridor. But as we move this AP up, now the signal launches itself down the corridor. All right, we are approaching the end. 5 minutes to go. Questions? Yes.
Nick, does Ekahau have any plans to add reflection simulation?
Okay, so reflections.
I really understand that this is a very heavy mathematical problem, but in fact, all the simulations are empirical. So, do you have any plans for that?
Okay, so does Ekahau have reflections? Currently, no, we do not. And that is under discussion. I don't believe that feature has begun development yet. I would encourage everybody to check out ekahau.com/feedback to add their support for such a feature. The one counter argument to reflection support is just how does one measure reflections? Whereas measuring attenuation of a wall I can explain how to do this quite easily, but measuring reflection is far more difficult. What I think, this is not Ekahau's view, this is Nick Turner's view, I think we could introduce such a feature and just have low, medium, and high reflectivity. I mean, that would be more, that would start to build a more accurate picture. But yeah, the counter argument that I have come up against with the development team there is related to how do you measure it, so therefore, how do you put that value into the software? Thank you very much for the question.
Is it possible to use directional antenna?
So the question was, can we use directional antennas? Yes, we can. So I will add that blank space again, set the scale, and then we come to the simulated access point tool. And do you have a directional AP in mind? Okay, no worries. We'll go for a 3702E with a 2566 patch antenna, and yes, we can drop one of those into the project here. And if I change that visualization back to signal strength, then it takes a little bit longer to draw, but then you can start twisting those APs, and of course you can adjust the tilt as well.
And I have one additional question about trial licenses for some of the Ekahau features, if it is possible.
So I'm in a difficult position there. If it was up to me, free trial licenses for everybody. They don't trust me with the licenses, so I don't know what the official stance is, but we have partners in Russia, and yeah, please contact them to request that, and then we can ripple those onto the Helsinki team.
Okay, thank you.
It is not an impossibility. I will do everything I can for you on that one. Guys, thank you ever so much. Oh, one more question. Go on, yeah, go on then.
Is there any plans to make an outdoor planning with terrain landscape?
Not in development that I'm aware of, but again, jump on user voice and share, because the thing with user voice is it starts to give you guys, the users of Ekahau, the ability to tell us what features you need. And the more people who vote on features, the more likely that those features will be developed. Thank you very much.
Thank you.